Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. Today I have with me Keith Moggach, Manager of Specification Engineering Team for Napco Pipe and Fittings, as well as Andre Battistin. He is Vice President of Napco Pipe and Fittings for North America. Today we're going to be talking about pipe materials, how they've changed over the years, and the increasing popularity and plastic pipe specification for water infrastructure projects. Thank you both for being on the call. I was very interested to speak with you about the pipe materials idea. I've noticed a lot of shifting and changing, but a lot has also remained the same. But thank you both for being on the call.
Thank you, Bob.
So the first question, I kind of wanted to set the stage about the different types of pipe materials that are currently used by municipalities in the U.S. and kind of how that's changed over the years. Could you speak a little bit to what is being used by municipalities at this current moment and in time?
Sure. Actually, currently, the most common material used in municipal water and sewer pipes in the U.S., it includes plastic led by PVC and ductile iron. Now, over the years, there were many different materials that were used. For example, in the 1900s, wood and brick and mortar were common materials, believe it or not. And in the first half of the 20th century, you saw clay, concrete, wood fiber. And in the 1940s, we actually saw some reinforced concrete pipe coming into play. I do want to mention that PVC pipe, which was first installed in Germany in the 1930s, became very popular in the US in the 1970s, and it displaced asbestos cement. And today, and from the 1990s actually, has become the dominant water main material installed in the US and holds a majority market share in small diameter sanitary sewer collection pipe.
Mm-hmm. Yeah, it's very interesting how many different types of pipe they are. Mentioning like the wood pipe, for example, I've seen some cross sections of those. It's very interesting to see how the engineering even has evolved over time.
Correct.
So could you talk about, so you talked a little bit about kind of how it's changed over the years. What have been some of the driving factors behind that? You mentioned specifically PVC pipe being popular in Germany in the 30s, but it didn't make it really popular here in the US for 40 years. What was kind of the reason behind that gap for us?
I can take this one, Bob. It's material selection, really, it's evolved as science, engineering, and manufacturing capabilities have evolved. I mean, pipes were originally made from objects people could source locally, materials they had at hand. Things like you were talking about, like hollowed out logs or wood stave piping or fired clay. They've since evolved to more manufactured and engineered materials like plastic and iron pipe. As the capabilities of the manufacturers have evolved, they've been able to bring these things to the market. Even within these modern pipe material families, there are subgroups that deliver different performance capabilities or take advantage of different manufacturing technologies. But regardless of material that's used, nearly all pipeline materials have evolved to offer greater pipeline capacity, handle greater pressures. They offer greater resistance to environmental and chemical exposure, and in general, they're easier to install these days. Material selection has also been driven by the historical performance of the pipes that were used by the prior generations. In the 70s and 80s, municipalities noticed that prior to what they were expecting, they're having unexpected premature failures of ductile iron pipe due to corrosion. This could occur on both the OD of the pipe and pitting of the OD or tuberculation of the ID. This also coincided with the health concerns about using asbestos cement pipe as a means of a corrosion-resistant water main material. A product was needed by the market that could meet the industry needs that was also immune to corrosion, and this is sort of the opportunity that opened up the market in the 70s for PVC to find its place. Mm-hmm. The reason why it took from the 30s until the 70s is because the time for the market to evolve and manufacturing processes to evolve to make plastic more widely available. And you see this through a variety of industries, not just the plastic pipe industry. As this was happening, new technologies emerged to inspect sewers in the 90s, and there was an increasing awareness at municipalities of the need for buried infrastructure asset management. I mean, municipalities were realizing that fixing pipe as it failed was costing them a lot more than they were taking in service rates for selling that water to people. This also coincided with the EPA consent decrees for combined sewer overflows, forcing buried municipal infrastructure to the front of the mind of politicians. I mean, nobody wants to get into a settlement with the EPA. I mean, as you can imagine, if there isn't a political will, it can be very difficult to generate the funding needed to fix an out of sight, out of mind asset, which is generally what you would consider buried water and sewer infrastructure. So in order to build out these asset management plans, municipalities started inspecting the condition of their sanitary sewer networks via CCTV inspections, and they started planning for water and sewer rehabilitation and replacement prior to the pipes failing. This also gave them a much better insight into what materials were failing prematurely, what the modes of failure were, and that led to them wanting to use different materials. So currently, pipe selection is based on a variety of considerations. The life expectancy of the buried infrastructure is typically expected to be 100 years or more now. There's concerns at municipalities about getting the best value, so that's led them to implementing like open procurement practices. There's concerns about the impacts of the installation method, and that's led to more pipe being installed via trenchless technologies. And engineers really do take a detailed, close look at the requirements of the pipeline and the physical properties of the pipe themselves when they're designing these now. And luckily for PVC, that is ideally positioned to benefit from these changes.
Mhm. Yeah, like you said, the installation portion about that, like horizontal directional drilling becoming a much more common use. That, I mean, you really can't do that with another pipe material type, as far as I understand it. So,
You need to find a way to have that pipe be able to handle the tensile forces that are applied to it in that environment. Yeah.
yeah. So, Andre, you had mentioned that just the market share of plastic pipe, how popular it is, and
Right.
whatnot. What makes it such a popular material to specify for pipe projects?
Actually, the trend towards plastics and PVC in particular, it really started as engineers became more aware of the corrosion issues that they have with legacy materials that had been installed prior to the trend towards plastic. And what municipalities are looking for is a product that is going to be safe, will last a very long time, and is proven, has a history of proven performance. So every municipality, they want to stretch their limited tax dollars. PVC allows them to do that. We know it has a 100-year plus expected lifespan, of the lowest break rate of any commonly installed water main material, and also a very low environmental life cycle assessment, the lowest of all materials currently used in the industry. So all of that is a strong value proposition for the municipalities.
Mhm. Now, we also know that Biden just announced this infrastructure plan proposal, and there's a lot of talk about replacing lead pipe, especially. What role can plastic pipe and other pipe materials play in addressing that issue specifically, and how do you guys foresee that occurring should that proposal make its way through and actually be implemented?
I'll mention one thing. One of the things that President Biden wants to do, of course, is make best use of the funds allocated for the infrastructure work. And PVC, because it's the lowest cost, highest value product available, meets that need. It's also environmentally friendly. It can be recycled 100%. It's the lowest life cycle cost of any other product. So it does fit very well with what President Biden wants to do.
Mhm. Yeah, Keith, would you like to add anything more to that about kind of the direction of this infrastructure plan, how these pipe materials could play into the roles of Biden's proposal?
Well, with plastic pipes, it does provide a good option for what they're going to eliminate lead service piping with. And that's typically where you find the lead that they're talking about in these systems, like in the Flint situation, is eliminating lead service, and plastic does provide an option for it.
Mhm. And one thing was curious about asking you guys about too. I know that it seems like obviously it's popular. It's a popular material for municipalities, but it also appears to me that it's a popular material in homes nowadays as well. Could you speak to kind of the role it plays in not only the municipal side and the municipal owned side, but what about the private owned side for the pipe there as well? Are you recognizing a similar trend?
Yep, PVC pipe and plastic in general is used throughout residential construction these days, whether it's to take the water away from your toilets, to bring the potable water to your tap. It's even used commonly as an electrical conduit to bring the power service to your house. There's applications for PVC throughout pretty much every conduit option you can find within a residential construction application.
Yeah, yeah. Well, and knowing about the residential side of things and how while the municipality could replace all the lead pipe in their system, if there's still lead pipe in the home, that presents an issue as well. So knowing that, plastic pipe can play a role in that aspect as well. It's not just limited to one side or the other.
Yeah,
Correct.
that's true.
Yeah. Awesome. Well, thank you guys. I appreciate you taking the time today. It's been great talking to you about the plastic pipe and kind of the growth of it over time. If you are watching and you want to get some more information on this, we'll have some links in our description below that you can learn more about plastic pipe and kind of the growth of it over time. Thank you both so much, Keith and Andre.